Well, hello everyone, and welcome to the webinars hosted by EDB. My name is Monica, and I am part of the marketing team here at Enterprise DB. I will be your host for today's webinar, an overview of reference architectures for Postgres. I am joined by Michael Wheeler today. He is a senior sales engineer here at EDB. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have any questions, please feel free to submit in the questions panel. Today's session is scheduled for 1 hour. We expect the presentation to last most of our time today, and we will allot any extra time for Q&A. If we do not have time to address all questions, we will follow up afterwards with any attendee whose question was not answered. And without any further ado, Michael, over to you.
Thank you very much. So today's topic is reference architectures, and this is the agenda. Short introduction into EDB. Talk about what is a reference architecture and the properties that are involved or inform such architectures. A list of core architectures and some add-ons to that architecture, and of course a summary and the Q&A at the end. So without further ado, let's go. So EDB was founded in 2004. Today we have more than 500 employees and more than 5,000 customers. 25% of those are Fortune 500 companies. Company is headquartered in Bedford, Massachusetts, with offices spread around the globe. What we do is all about Postgres. We deliver support, services, and tools that enables customers to deploy Postgres into enterprise environments with such things as high availability and so on. We've been have more than 25 years of Postgres focus. And today, with the acquisition of Second Quadrant, we are the largest Postgres-focused company in the world. So, reference architectures. In this presentation, what we call the reference architecture is kind of a building block. It's a way to build your entire application or your entire application architecture and understand each of those components in the architecture, and by doing so it's easier to understand the entire architecture. The ones that are available on GitHub, which there will be a link to later on, are ones that have been tried and tested and are easy to understand, easy to try out, and can be used as the foundation for your application architecture and your database architecture. So let's talk about the properties of architectures, database architectures in general. There are 4 of them. The first one is recovery time objective, which the short version of what recovery time objective is how long does it take you from your server, your database server, primary database server has failed, until you are up and running again. That is what RTO actually is. And with that, you have to be aware that if the server fails, the node that the database is running on fails, and all you need to do is restart it, then a failure is easy to recover from. But if you need to go back to a database backup or even an operating system backup, then it takes longer. And so that is the metric that you need to take into account here. Recovery point objective is the second property. In short, this is a measure of acceptable data loss. The way that this means that if you have committed transactions and your database fails, will you be able to recover those committed transactions, the transactions that happened in the past couple of seconds or maybe even hours? Are those available once you have recovered your database? If you have to resort to a backup, revert to a backup and restore from there, then your transactions, the newest transactions may not be recoverable, and so you've essentially lost those transactions. This is measured in minutes or even hours or even days. If you have a situation where your backup is 2 days old and you cannot recover, then you have lost 2 days worth of transactions. All of these properties are in themselves targets, so they inform your choices on architecture. So if you cannot accept, for instance, a few hours of data loss, then you need to build an architecture that insulates you from that data loss. The next one is geographic redundancy objective. Here we're talking about being able to survive a complete loss of, for instance, a data center. If your entire architecture and your databases, your failovers, and whatever else we're going to get into is situated in one data center, and that data center suffers a complete loss of power or even flooding or something like that, then you've lost your data center, you've lost your databases. Will you be able to conduct business afterwards? Your backups may be somewhere else, but you have no hardware to run them on. So what do you do now? So this is what geographic redundancy is all about. And the last one, and the most well-known one, is target availability. This is where we talk about number of nines, so 99% uptime, 99.99% uptime, and so on. The degree in which a system is available, the amount of time where the system has been available measured across a month, a quarter, a year. And in this case, in the top right corner here, we have some numbers for availability seen across a year. So with 99%, it's you can suffer, you are allowed to be unavailable for 3 days and 15 hours, as opposed to with 6 nines at the bottom, where within a year you don't meet your required uptime if you have more than 31 seconds of downtime during that year. Now, again, a target is not a guarantee, and it is affected, and you need to take into account all the factors and dependencies that your database has, and that would be the operating system, the hardware that the server is running on, the network connecting you to your clients, the environment, things like cooling and power, but also things like upgrades and maintenance windows during the year. Usually in an SLA, they are not included in such a thing, so that if you need to do an upgrade of your database, that counts against your SLA and your uptime.